Welcome to this introductory video on Spring AI Framework. After watching this video, you will be able to identify components of Spring AI, describe the Spring AI Framework, and explain the benefits of using Spring AI with Java. Artificial intelligence is evolving fast, and Java developers now have a more powerful tool known as Spring AI. Built on the popular Spring framework, Spring AI makes it easier to add AI features to Java applications. It connects your app to various AI services, offering a consistent way to work with different models. There's no need to learn each one from scratch. The key components of Spring AI include AI models, prompts, embeddings, vector databases, and output parsers. Let's explore each of these and how they work with Java. At the core of Spring AI are the AI models that perform tasks such as generating text, analyzing images, or processing natural language. Spring AI supports various AI providers, including OpenAI, Anthropic, and Azure OpenAI. For beginners, it's important to understand that these models are pre-trained AI systems that can perform specific tasks. You don't need to train them yourself. Instead, you connect to them through Spring AI and send them requests. The framework abstracts away the differences between these services, allowing you to switch between them with minimal code changes. This is similar to how Spring's Java Database Connectivity, or JDBC, templates let you switch between different databases without changing your application code. Prompts are the instructions you send to AI models. Think of prompts as the questions or commands you give to the AI. The quality and clarity of your prompts greatly influence the results you get. Spring AI helps you manage and organize these prompts effectively. You can create template prompts with placeholders, such as topic, which gets replaced with actual values when used. You can also store prompts in configuration files that are separate from your code, and you can reuse prompts across your application. For beginners, this means that with Spring AI, you don't have to hard code your AI instructions in your application. You can define them centrally and reuse them throughout your application, following good software engineering principles. Embeddings are numerical representations of text, images, or other data that capture their meaning in a way computers can understand. For example, in an embedding, the words happy and joyful would be represented by similar numbers because they have similar meanings. This allows AI systems to understand relationships between concepts. Spring AI makes it easy to generate and work with embeddings, essential for semantic search or finding content based on meaning, not just keywords. Embeddings also help with document comparison by identifying similar documents and building recommendation systems. Embeddings enable your applications to understand the meaning behind text or other data, going beyond simple keyword matching. When working with AI, you often need to store and retrieve embeddings efficiently. This is where vector databases come in. Unlike traditional databases, optimized for text or numbers, vector databases are designed to store and query embeddings. Spring AI provides integrations with popular vector databases, making it straightforward to implement features such as semantic search or recommendation systems in your applications. Think of vector databases as specialized storage systems that let you find information based on similarity rather than exact matches. AI models often return unstructured text, but your application might need structured data, such as JSON objects or specific formats. Spring AI's output parsers help convert AI responses into formats your application can easily work with. With Spring AI, you don't have to write complex parsing logic to extract the information you need from AI-generated text. One of the simplest ways to start with Spring AI is by generating text. You can start by creating content for blogs or social media, generating product descriptions, drafting emails or messages, and creating summaries of longer documents. Spring AI makes it easy to send a prompt to an AI model and receive generated text in response. Spring AI can help you build chatbots or conversational interfaces that understand natural language and provide helpful responses. The Spring AI framework handles the complexities of maintaining conversation context and generating appropriate replies. Using Spring AI's embedding capabilities, you can analyze documents to extract key information. You can also categorize documents by topic and find similar documents. Additionally, the embedding capabilities can help you answer questions about document content. There's also Smart Search functionality. By using embeddings and vector databases, you can implement semantic search in your applications. This allows users to find information based on meaning rather than just keyword matching. To get started with AI, start simple and begin with basic text generation or simple question answering before moving on to more complex AI features. Spend time experimenting with different prompt structures to get the best outputs. The way you phrase your prompts significantly affects the results. Also, manage cost and performance. Many AI services charge you based on usage. Be mindful of how frequently you're calling these services and how much data you're processing. Additionally, implement caching. To improve performance and reduce costs, consider caching AI responses when appropriate. In this video, you learned that Spring AI, built on the Spring framework, simplifies the integration of AI features into Java applications by connecting to various AI services, such as OpenAI and Anthropic, without requiring AI expertise. Key components of Spring AI include AI models, prompts, embeddings, vector databases, and output parsers, which help manage and organize AI interactions effectively. The framework abstracts the complexity of AI services, allowing developers to switch easily between different models and integrate advanced features such as semantic search and recommendation systems. Spring AI enables beginners to build smarter apps by simplifying tasks such as text generation, document analysis, and chatbot development without complex parsing or code changes. Best practices include starting with basic features, experimenting with prompts, managing costs, and implementing caching.